All right. So today is Tuesday, the 15th. We've already completed the warm up. I'm going to go over comparing functions, just a quick review of that. Then I'm going to model again GCF, and we're going to do factor by grouping today. Okay. Tonight is the animal project. At the end, I'm going to give you just a little time to meet with your partner. If we don't have that time, then I'll give you the time tomorrow because tomorrow's a longer day. Today is kind of a modified day. So if we don't have that time today, we can do tomorrow. Tonight, you're working on finishing up your animal project and makeup work. Please do not forget that you need to be taking pictures of your interactive notebook and uploading it to Canvas. Your interactive notebook is due Monday. Okay. Questions, comments, or concerns? All right. Warm up, you should already have the warm up completed. The initial height, that means you got to go back one to figure out what the zero number is. How do you get to the next number? What are you doing to get to the next number? Which is multiplying by what? Work backwards. You say 12 divided by 18 to work backwards.
1/3.
What's 12? 12 divided by 18. Math. Enter. It's 2/3. So you're multiplying by 2/3. So you're going to say, when you're working, you're going backwards here. I'm sorry. So you're going backwards here. So multiplying by 2/3. So we're going to divide to go backwards. What did we get there? What does that give you? Nope. 18. You're working
12.
backwards. Divided. How'd you get 27? 18 divided. We're working backwards. Divided by 2/3 this way. If you multiply 2/3 this way, it's dividing by 2/3 this way. And that's going to give you 27. So the initial height is 27. Okay. That's your zero number. You're multiplying by 2/3. Okay. The rate. So you're going to use B is equal to 1 minus R. So you got B is equal to 1 minus R. Your B, in this case, is the 2/3. So to get R by itself, you're going to subtract 1 on both sides. So what is 2/3 minus the 1? It's negative what?
Negative 1/3.
Negative 1/3. Okay. Divide both sides or multiply both sides by negative 1. And that's going to give you a positive 1/3. What decimal is 1/3?
0.3 repeating.
0.3 repeating. So if I want to write this as a percent, I move the decimal over 2 times. This is 33.3 repeating percent. So that's the rate here. Sorry, I put the formula. Let's put the real numbers. It's 0.33 repeating, or if you write it as a percent, all right, represent this as an equation. That's going to be y is equal to what?
Y is equal to 20.
27. 27. That's the starting times. What's the
times 1?
1/3. Who said 2/3? That's B. This is B. And then what? To the power of x, or to the x power. Okay, after the 8th bounce, what would it be? What do I do to figure that out? plug in 8 for x. So that's 27 times 2/3 to the 8th power. And you get your answer that way. Any questions? All right, I'm going to pause for the calls. Please take out your notebook. Your planner first. Let me write the planner. Sorry. Planner. I'm checking your planner next week, Tuesday. All right, so today we're working on Animal Project. Math 1. Homework. Animal Project. Any questions? Yes. What's tomorrow?
Wednesday.
So it's Thursday. All right. Tomorrow is we take our reading quarter test tomorrow. So our schedule is going to be a little bit different. We're going to have a different scheduling. Okay. We also have our tutoring tomorrow. Virtual tutoring. If you need to meet with your partner, you can do it at that time. Okay. If we don't get to meet with our partner today, we'll meet with our partner tomorrow because it doesn't look like it because of time. All right. Our makeup work is due. All makeup work is due on Friday at 11:59 p.m. No, I'm not going to open anything back up. Okay. Whatever is not submitted at that time will be a permanent 0. Questions, comments, or concerns? Friday at 11:59 p.m. is the absolute last moment. Any questions? Okay. All right. Let's take out our notebook, please. All right. Our page 26 was factoring GCF. And there were a few problems that I wanted you to do completely on your own. Here, come get one thing. Johnny, can you go sit with Miss Barletto, please? Thank you. Watch this video later, okay? Have a great day. Shh. All right. Make sure you watch the video later. Okay, so the couple that I'm going to be doing for you, we did some of these yesterday. Let's check to make sure that you have it right. Let's do number 10. Please make sure that you have these right. I'm going to go through that, and then we're going to do factor by grouping. All right, so with number 10, make sure I wrote that right. Negative 8x to the 7th plus 24x to the 6th plus 12x to the 5th. All right, so we're going to factor this polynomial by figuring out which two polynomials can be multiplied to give you this polynomial, okay? All right, so first things first, we're going to do it by GCF, so we're going to find, close your laptop. So we're going to find the GCF of all 1, 2, 3 terms. So out to the side, we have this negative 8x to the 7th. Then we have positive 24x to the 6th. Then we have a positive 12x to the 5th. Okay. This is a negative, so this is going to be negative 1. The prime factorization for 8 is going to be times 2 times 2 times what?
4.
2.
Oh,
You got to
2.
break it down to all primes. 2 times 2 times 2 is 8. And then we have 7 x's. 1, 2, 3, 4, 5, 6, 7. Okay. All right, 24. When we break down 24, so you can physically see it, this is 2 times 12, circle 2. Then this is 2 times 6, circle 2. And this is 2 times 3. Guys, ladies, y'all, come on. All right, we got 1, 2, 3 twos. And 1, 3. And then 6 x's. 1, 2, 3, 4, 5, 6. 12, when we break 12 down, is 2 times 6 and then 2 times 3. So that's 2 twos, 1 3, and 5 x's. 1, 2, 3, 4, 5. So now we're going to circle all that's in common. They got a 2 in common. They have another 2 in common. Okay, and how many x's do they have in common?
5.
They have 5 x's in common. 1x, 2, 3, 4, and 5. So this gives us GCF, and put it over here. That gives us 2 times another 2, and then 5 x's.
4x to the 5th.
Huh? 4x to the 5th, yeah. So GCF is 4x to the 5th. So that's what we're going to take out. That's one of the factors. What can be multiplied times 4x to the 5th to get this negative 8x to the 7th? What's left? You got negative 1. You got 2.
Negative 2.
X to the what? To the second. It's 2 x's that are left. You took out 5, you got 2 left. Okay. What can we multiply times the 4x to the 5th to get positive 24x to the 6th? What's left?
6x.
Okay, positive 6x. Okay. And what's left here? What can we multiply times 4x to the 5th to get this 12x to the 5th?
3.
Just the 3 is left here. Okay. And these are my factors. These two, this monomial and this trinomial multiplied together is going to equal this trinomial. That's how we factor a polynomial. These are the two factors for that polynomial. Any questions?
No.
So now we're going to do factor by grouping. This is Q3, quarter 3, and this is page, I want to say 27. It is page 27. And we're going to factor by grouping. Any questions about factoring GCF? Right? Are you listening? Are you writing this down? Factor by grouping. I'll pause to give you a chance to get there. All right, so when you are factoring by grouping, this is how this works. Let's do number 1 on the sheet. It's no special formula or anything for us to write. I'm going to model it. First thing that you always look for is you're going to look to see if there's a greatest common factor. Always do that first. So number 1, look for GCF, greatest common factor. Always do that first. When you're factoring any polynomial, this is key. This is so important. Put a star beside it because that's how important it is. You're always going to look for GCF first to see if there's a greatest common factor for all of the terms. In this case, there are 4 terms. 1, 2, 3, 4. Terms are separated by addition and subtraction signs. So there are 4 terms. There is not a greatest common factor for this other than 1, okay, for all 4 terms. So now we're going to do what you call factor by grouping. That means we're going to find the GCF of 2 at a time. We're going to find the GCF of the first 2 terms and then find the GCF of the last 2 terms. That's how you do factor by grouping, okay? All right, you ready? So let's do the first 2. Okay, so number 2, with factor by grouping, you're going to find the GCF of the first 2 terms, then find the GCF of the second 2 terms. Find GCF of first 2 terms, then the last 2 terms. Okay. And you can only do this when you have 4 terms. When the polynomial is 4 terms. So you only do this with 4 terms. Okay, super important. All right. So let's find GCF of these first 2. Okay, so let's do that. I'm gonna do it out to the side. So we got 12a to the third, and we got negative 9a to the second. So we're gonna do the prime factorization for both. So when we break down 12, what 2 numbers will give us 12?
3 and 4.
3 and 4. We circle 3 because it's prime. Break down 4 to what?
2 and 2.
2 and 2. So the prime factorization in order from least to greatest is 2 times 2 times what?
3.
3. And then how many A's?
3.
3 A's. Okay. Now we're going to do negative 9. So it's a negative, so we got negative 1. Go ahead and factor that out. And now we're going to break down the 9. Okay. What 2 numbers?
3 and 3.
3 and 3. They're both prime. So here we have the prime factorization is 3 times 3 and how many A's?
2.
2 A's. Okay, so our GCF here, what they have in common, they have a 3 in common, and what else?
2 A's.
2 A's. So our GCF is going to be 3A squared. So watch what I do here. I put the 3. Am I moving too fast? Slow down. Okay, 3A squared. And what number can be multiplied times 3A squared to give me this 12A to the third? What's left?
2A. 4A.
4A. Okay, and 3A squared times 4A gives me this 12A to the third, okay? So let's do this one now. All right, what can I multiply times this 3A squared to give me a negative 9A squared?
Negative 3.
Okay, negative 3. You see how negative 1 and 3 are left? So it's negative 3. So we've taken care of that. All right, so now let's find the GCF of the last 2 numbers. Okay. Alyssa, are you okay? Are you writing this down? What's wrong? You're distracted today. Are you okay? All right. So we got 4A and negative 3. So when we break this down, we get 2 times 2 times A. Does everybody understand how I got 2 times 2 times A?
Yeah.
Then we get negative 1 times 3. Everybody good with that?
Yes.
They don't have anything in common other than 1. Do you understand that? Automatic GCF here is 1. That's the only thing they have in common. So we're going to take out a positive 1. When we take out that positive 1, we're still left with 4A minus what?
Minus 3.
Minus 3. Any questions about what I did?
No.
Okay, so now this is going to be the absolute last step here. Okay, notice this. This is the part where people get kind of confused. So please stop what you're doing and just listen to what I'm saying so that it doesn't become confusing. All right. What you notice is that these two numbers right here are now being multiplied by the same binomial. Do you see that?
Yes.
Okay, since both these two numbers are being multiplied by the same binomial, you can write these two numbers together in a parentheses like this, plus 1. And then right beside it, have it being multiplied by this number right here, this binomial, which is 4A minus 3. And these are your two factors. This would be your answer. Okay. When I remultiply this back out, this is the previous line before it, if you notice. Because when I do distributive property, I'm going to say this number times this, and then this number times this. So that's the line that's before it. Okay, so that's why, since they're being multiplied, you see these two terms right here? They're being multiplied by the same binomial. So you can put them in a parentheses together and then have it being multiplied times that same binomial. These are the two factors that if I was to remultiply these together, I would get this as my answer. So these are my factors for this polynomial. Yes.
So that only works if they're multiplying the same.
It only works if it's 4 terms. And the other second part of your question, it only works if these what's in the parentheses is the same. If they're not the same, then you have to leave this as the answer. Okay. Any questions? All right. Let's do 2 the same way. Okay. Number 2. Until you kind of can get a pattern, and then we'll do a couple on our own or a few on our own. We have 2p to the third. Is everybody okay though?
Yes.
Okay. Then we have 5p to the second plus 6p plus 15. We all right? All right. It's 4 terms. We're going to do the same thing. We're going to look for GCF of all 4 numbers. There is no GCF for all 4 of these numbers. They don't all have something you can take out other than 1. Okay, there's no GCF other than 1 for all 4 terms. So you're going to do the second step, which is to find the GCF for the first 2 and then find the GCF for the last 2. So you're going to find the GCF for these first 2 and then find the GCF for the last 2. So let's do that out to the side. We have 2p to the third and we have 5p to the second. So let's write the prime factorization for both terms. What's the prime factorization for 2p to the third?
1 times 2.
We could write 1, but we don't really need to because it's, it's a positive.
So just 2 times p times p times p.
Very good. Hatcher, are you okay? You look like you lost. Are you sure? Okay. What's the prime factorization for this second angel? How do we break 5 down? What you think?
I think it's 5 times p times p.
5 times p times p. And 5 angel is a prime number. So that's why you can just write 5 because it's already prime. If it's composite and you can break it down to 2 numbers other than 1, then you break it down. Does that make sense? Are you sure? So now we're going to circle what they have in common. What do they have in common?
2 P's.
Okay, they have 2 P's in common. So my GCF is going to be what? P squared. Cooper, sit up. Please don't do that, honey, okay? All right, so we're going to take out P squared. What do I multiply times this P squared to get 2P to the third? 2P. You see how 2P is left? So this positive 2P. What can I multiply times this P to the second to get 5P to the second? 5. You see how 5 is left? So it's positive 5. So now we're going to do GCF for these two. Jacob, are you okay? Are you stretching or are you ready? You got a question? Okay. 6P and 15. All right. How do we write the prime factorization for the number 6P? Ian? Break down 6, babe. What two numbers can be multiplied to give us 6? 3 and 2. Okay. So then how do I write the prime factorization for 6P? What comes first? 2. Are you listening? What's wrong? Was you in the twilight zone for a second? Okay. Times P. All right. I caught you off guard. I didn't mean to. 15. Let's break down 15. What two numbers can be multiplied to give me 15? Yes. Very good, baby. 5 and 3. So how do we write that prime factorization of that number, Sammy? Turn the music off, honey. You can't possibly really understand what I'm doing. No, hearing me and listening to me is two different things. Do you understand the difference between the two? Okay, so I need you to listen to me, not just hear me. What's the prime factorization for? Did you pick it up off the printer?
No.
It's on the printer on this hall. You're welcome. It's 3 times 5. Okay, very good. What's going to be my GCF here? What do they have in common? 3. So my GCF is 3. Please pay attention, y'all, because when you have to do this stuff on your own, you'll have less questions if you're paying attention. Okay, so we're going to take out a positive 3. So this is plus 3. Now let's look. What can we multiply times this 3 to get 6P? 2P. So this is 2P. It's positive 2P. You see how 2P is left? Okay. What can we multiply times 3 to get 15? 5. Positive 5. Do you see how positive 5 is left? All right. So here we go. Look. What do we notice about these two terms?
The binomials are the same.
They're being multiplied by the same binomial. So then how do we write the next line if they're being multiplied by the same binomial? Yes.
You would write it p to the second plus 3
Mm-hmm.
parentheses close parentheses then 2p times 5
Plus 5. Mm-hmm.
plus 5.
Okay, do you see that? These two factors, if I was to remultiply them, I would get this as my answer. Okay? And I use distributive property twice, what do I say? I say 2p times this, which is that, and then 3 times this, which is that. Okay? Any questions? These are my factors. These two binomials can be multiplied together to give me this. Are you okay, Katie, with this? You sure? Okay. Are you okay with it? Raise your hand if you're okay with it. Thumbs up or raise your hand so I'll know what I'm looking at. Okay. All right. Okay, let's do number 3. Anybody still copying too? Okay, so let's do this one. We have 3n to the third power minus 4n to the second power plus 9 minus 12. Okay? Again, 4 terms. Okay? These are 4 terms. So we always look for GCF for all 4 terms.
It's 9n.
9n. Thank you. Thank you. All right, so let's look for GCF for all four. Is there a greatest common factor for all four? Do they all four have the same factor?
No.
They do not. Okay, they do not. So we have to factor by grouping, but always look for that first, okay? All right, so here we're going to find the GCF of the first two and then the GCF of the last two, okay? Come on, Alyssa, poor thing. Come on, baby cheeks. Take some paper out, copy this down. You'll thank me later on in life. Just not this year, okay? This year you won't. You'll be like that heifer. But the next following years, you're gonna be like, I'm glad she did that to me. But just won't be right now. All right, which is okay. It's fine. So let's do greatest common factor. 3n to the third, and then we got -4n to the second. So let's prime factorization for 3n to the third. What's the prime factorization? Kirsten, what's the prime factorization for 3n to the third? 3 times, all I heard was 3, sorry. Very good. Okay. What's the prime factorization for -4n to the second? Yes, go ahead.
-1 times 2 times 2 times n times 3.
Very good, babe. Okay. Any questions about how we came up with the prime factorization for both? Dalton, are you writing this down? Come on now. Bless your heart. Okay. All right. So now we're going to find the GCF. What do they have in common? Riley, what do they have in common? They have 2 n's in common. So we got this n and we got this n. Okay? So the GCF here is what?
N squared.
N squared. All right, so we're going to take out an n squared, okay? Thank you. Come.
Do you have any extra math?
I don't have any more, babe. I'm sorry. All right, so what can I multiply times n to the second power to get 3n to the third? Yes.
You can multiply 3n.
3n. You see this is left, 3n? Okay. What can I multiply times n to the second to get a negative n to the second? -4. You see how this, when you multiply together, -4 is left? Okay, so we did this part. Now let's do the second part. Out to the side, we have 9n, positive 9n, and we have a -12. We're going to write the prime factorization for both. All right, what's the prime factorization for 9n, Sammy?
3 times 3 times n.
3 times 3 times n. Good job. What's the prime factorization for a -12? Very good. Okay. Now what's going to be the GCF? Ian, you ready to answer? Okay. Come on. I need you to pay attention, okay? Because I'm going to come back to you. Javier? 3. Okay. They have a 3 in common. So GCF is 3. So we're going to take out a positive 3, right?
Mm-hmm.
So we put +3. Notice little details that Miss Reyes is putting +3 because it's a positive 3, okay? What can we multiply times a plus or positive 3 to give me 9n? Yes. We got 3n. You see how 3n is left? Okay. What can we multiply again times this positive 3 to get a -12? Yes. -4. You see how -4 is left? All right. Very good. So now, what's the last thing that I need to do? Yes.
Combine the binomials.
Okay. And tell me how to write that.
Parentheses n to the second plus 3, close parentheses, open 3n minus 4, close.
Very good. Excellent job. These two binomials, when you remultiply these together, it's going to give you this polynomial as an answer. Okay, I need you to do the next one on your own. I need you to go ahead and do that now, please. We got 1 minute after the bell anyway. This you need to do on your own.